Hey everyone, welcome to this tutorial on how to use the Midsurfacing tool in Ansys Discovery, which will help you reduce the number of nodes and elements for your structural analysis. Before we move forward, let me quickly remind you how you can access Discovery. So one option is go over to the Start menu in Windows and then navigate to Ansys 2022 R1 and further navigate to the Discovery tab, which you will find right here. The other option is head over to Ansys Workbench, and under Component Systems, you now have a Discovery option. Also, if you have an analysis system open, say Static Structural, right-click on Geometry, and in addition to Space Claim and Design Modeler, we now have this new Discovery Geometry option. So you can directly access Discovery through here as well. Okay, so back to Discovery. This must look like a familiar welcome page if you've been following our other tutorials, but I highly recommend to go through all of these and get familiar with how to get up and running with Discovery. Also highly recommend these interactive tours and especially this beams and shells one, which might be super useful for those of you watching this video. Okay, so let's go to our home page and click on Browse to open the geometry file. Navigate to the right folder, click on the file, and click on Open. Now, this should get us to the LiDAR assembly model that we're working with today for this midsurfacing tutorial. But before we get started, one quick tip for those of you who plan to use Discovery primarily as a geometry prep for simulation tool. So to remind you, there are three modes: model, explore, and refine. So the refine mode and the explore mode are simulation modes, whereas model mode is for our geometry prep for simulation. So keeping that in mind, if you go over to settings right here, make sure that your default stage for new documents is selected to be model, as is the case right here. Typically, it is set to explore, but if you change it to model like I have, then every time you open Discovery, it automatically opens up in this model stage, and it helps you just streamline your workflow a little bit. Okay, so back to mid-surfacing. Our mid-surfacing options are under Prepare right here. So if you go to the Prepare tab, you'll see we have this new beams and shells options right here. And this is where we're housing our mid-surface tool right here. So before I get to that, let me just go through the geometry tree that we have here. So we have the cameras, our LiDAR block, and a bunch of cross beams in brackets here. Now we only want to use the mid-surfacing tool on our thin structures or stuff made out of sheet metal in this case. So let me hide the LiDAR and the cameras by clicking on these two buttons here. Now we have the part of the assembly that we want to use the mid-surface tool for. So click on mid-surface, and this will open the mid-surface tool here. We have tool guides on the left and tool options on the right. And through this tutorial, we're going to walk through the different options that we have here. So there's two primary ways to use the mid-surface tool. It's either through the selected faces or through the use of range. So by default, we have selected faces. So let's look at that a little bit first. So let me zoom in so we have a better look here. If you look at the instructions at the bottom, it says select a pair of offset faces. So that should give you a hint that we have to select two faces, two offset faces, for which it will create a mid-surface. So let me click on this face right here, and you'll see that the next time I hover over this, it automatically selects the offset, which makes the overall experience pretty easy in terms of selecting two offset faces. So we have a green and a blue signifying the two faces that we have. Now we don't need to do this one pair at a time. So within the same selection, I can look at other pairs. So let me select this one and the offset behind it. And similarly for this triangle and the offset behind it. So now we have three pairs selected for our mid-surface. And let me click on complete. So we'll be able to look at what's been created. So here we see that for our selections, we have the right mid-surfaces created. And these are housed in our overall geometry tree right here. So if you look at this component right here, we can see all the different mid surfaces associated attached here. And we can click on this arrow and then update the thickness that you want for the part. So it can be different for each of these, or you could change it right here, which will change the thickness for all the parts in that component of mid surfaces. Let me just click on undo so we can go and understand some of the other options that we have available. So under the component, we see that we have either same or active. What this does is if you've selected active, which is the case by default and what we're working with right now, it will create the mid surfaces in the overall active part of the geometry tree, which in this case, if you look, is the overall LiDAR assembly mid surfaces itself. So this is why it put it under as a completely new component. But if you were to use the same option, what it would do is put those mid surfaces into the individual components that it was associated with, which in this case would be the three of these. But I personally prefer my mid surfaces to be grouped in the overall highest level of the geometry tree right here. So I typically leave this on active. In terms of mid-surface location, you see that we have three options: middle, bottom, and top. Obviously, this means where the mid-surface is created. For us, it makes sense to leave it on middle, but you do have the option of creating that mid-surface either on the bottom or the top of the offset faces that you've selected. Now, one important option here is extend surfaces. So this is a really neat option because it automatically extends your mid surfaces to have a continuous contact between the 2D representation that you will create. So let me turn this off and this will give you a better understanding of what's going on. So once I turn that off and I click this check mark, if I were to now zoom in this view, you'll be able to see that we have a certain gap between this face right here and this edge. Let me just go back to the Z view and this edge right here. So now we have this gap in the middle, which is obviously not ideal, which is why that extend faces is a really handy option. So let me just get this back into view and click on undo. And this time I am going to make sure to select extend surfaces. Okay, so that pretty much sums up the way in which you can use selected faces. But for a complex body where, let's say, you have 10, 20, 100 different mid surfaces that you want to create, doing this using this manual option isn't probably the best way to go about it, which is why we also have this use range option. So in this case, we can specify the minimum and maximum thickness boundaries for which we'd like to create mid surfaces. So in this case, we have some numbers selected. Let me just make this 0 to 8. And now what we need to do is select the bodies where you'd like for this search to be implemented. So to select all the bodies that we see, create a box left to right around the assembly. And here you'll be able to see that it selects all these thin structures available by sorting it between blue and green bodies, essentially selecting all the different offset faces that exist. Now I'm going to leave this as active. So we have a separate mid surfaces component in our geometry tree. Leave it at middle, extend all surfaces, and click the check mark. And once we do this, it's automatically going to go ahead and create all the 2D representations and the mid surfaces for our assembly. So here we see with a very easy click of a button, it automatically generates the mid surfaces and puts that in the highest order of the geometry tree here under mid surfaces. And we have a bunch of different mid surfaces to work with. Now, depending on how these were set up and what the inherent thickness was, they have different thicknesses. Let's say some of them have 5, some of them have 4.2 millimeters, but you have the option to go in and change each one individually, or you can change it at the highest level here. So now you have the option of doing that as well. So that pretty much sums up how we can use the mid-surface tool, both using selected faces and using a range, to create a bunch of mid-surfaces that can now be used to do simulation in a more efficient way. So having said that, now let's look at how we can actually transfer our geometry prep work that we've done here to Workbench and then connect it to an analysis system and see what it looks in Mechanical. So to do that, click on Workbench here. And now within a few seconds, it's going to transfer this geometry over to Workbench where we can take a look at what it looks like. So just give this a minute. Okay, so we see here that it's connected this discovery geometry in our Workbench project schematic. Let's just connect a static structural to this geometry and take a look at what it looks like in Mechanical. So once this is connected, click on Model here, and this will open up Mechanical. So again, just give this a minute and let's take a look at what it looks like. Okay, so we see that the geometry is transferred over to Mechanical. And under our geometry option here, we see we have a bunch of the solid bodies and a bunch of all the surface bodies, or the mid-surfaces in this case, grouped at the bottom here. So just to be able to see this better, let me right click and hide all the solid bodies. So we're only looking at the surface bodies, and here you see we can take a look at exactly what we set up in Discovery available in Mechanical. And if you were to go into any one of these mid surfaces under our details, we can see that the model types are shells, and we can update the thickness here as well, just like you could in Discovery. Okay, so that wraps up our tutorial for today. Hope you found this useful, and please take a look at all the other videos we're creating for Ansys Discovery. Thank you so much.